Designing and engineering the Dyson PureCool Purifier was more than just creating an effective purifier. Dyson engineers questioned, scrutinized, and crafted every part of the machine, designing it to have a small footprint, to fit anywhere in the home. The remote control is curved and magnetized, so it can dock on top of the loop for easy access. The integrated auto mode takes over cleaning the air for you, monitoring the air quality and reacting accordingly when the air becomes polluted. And for the light sleepers, we've programmed a nighttime auto mode. This enables only the quietest settings, as well as dimming the display. And during warmer days, the machine can cool you. Changing filters is easy with Dyson. Observe the air quality inside your home and outside. The Dyson Link app contains purification activity, filter life, and remote control, including scheduling. The Dyson PureCool Link Purifier.
I'm Dominic Mason. I'm the head of category for environmental control here in Southeast Asia. This year I will be 21 years at Dyson. So been working on lots of stuff. We're not a market research focused business, so we are engineering focused. So we're constantly trying to fix problems. New design and new iterations come from our development process. So we'll usually try and find a problem that we want to fix and then develop a product to fix it, as opposed to trying to find a good sales opportunity, for example. So it's all about solving problems. We get lots of feedback from customers. So everyone's got a feedback device in their pocket these days, so we get feedback through our application, through the internet, we get through our helpline, and lots of different media that helps us. But more than anything, all of our engineers are trained, and the type of people that we like to have are creative, inquisitive, difficult people who are unhappy with the status quo. They want to make things better all the time. So when we've put a product into production, I'm really, really happy with this product, but I know that there's stuff we could do better. If we continue to reiterate and make things better and better and better, we would never put a product into production. We'd be fiddling with it all the time. So the way that we approach it is to try and get the very best we can out of the product within a decent time frame. And you mentioned, the filter's denser, so we want better filtration, but we want better filtration with the same power consumption. So we don't want to make the motor spin faster, but we want the same performance. So we'd set ourselves that challenge. So other places would do a very simple change. We'll just make the motor faster and we'll get the same performance. But we don't want to do that because we want the same power consumption. So we set ourselves very challenging targets in order to keep the products how we feel is the right size, shape, performance, acoustics, all of those things. So it's a very challenging environment to work in, and fortunately or unfortunately, depending on how you look at it, we never take the easy route. So we're always very challenged to deliver the best product in the best package.
So you said that you would like to see some changes in the next iteration. So what would the changes be?
The changes would be better, more advanced filtration, better, more advanced sensing, all of the things that, but for me at the moment, it's not just about the product, it's about what we're trying to solve with the product. So air pollution or indoor air pollution, the more work I've done on it and the more research our research team does on it, the more you find. It's kind of, the more you test, the more problems you find. And we have a very high level of filtration, so 99.95% of PM 0.1 particles. Those particles are the ones that get past the cilia and other bits of your lungs and into your bloodstream. PM10, PM 2.5, it's all quite interesting, but for us, it's kind of, those aren't the big, they're too big. We want to be heading for the smaller ones. What levels of sensing can we do? If I could have my way, there'd be a scientific laboratory in here that could tell you everything you need to know, what it is, what it's doing. That the options are endless, and being an engineer and being lucky enough to work at Dyson, I have the opportunity with our teams and our huge research, £8 million a week on research, huge dedicated research teams in the UK. I mean, we're privately owned, so we can take risks and we can really try lots of different things. We have James to satisfy, and he's the kind of man who will want us to do nothing but the best. So all of those opportunities are there, and for us to try and improve.
Since India is your new market,
yes.
and the air conditions in India are not very good. They're
yes.
actually really, really bad. Would you consider customizing the product, especially the air purifier, for India? Maybe something more, because for us it's so bad that a lot of people are dying and suffering from bronchial issues in just like past few months, and especially in winters in November and all, gets really pathetic. So would you consider customizing the product or adding something more to it for the Indian market?
So I think I'm learning quite a lot about the Indian market, and the fact that the sort of October, November, December times are bad, but also you've got some very bad pollen months as well, down in the south. Those aren't necessarily the winter times. Crop burnings. So, I mean, we were talking about it the other day, and you've got it all.
And the recent dust storms.
Yeah,
pretty much throughout the year.
You've got industrial pollution, car pollution, natural pollution with pollen. Then you've got smoke, the whole lot. Customizing specific products. So the way that we've approached it is to make sure that our products are they can sense the pollution in and around the room. So the sensors will notice pollution, and then they will sense to see how heavy that pollution is, and then the machine will react to it. So having our auto mode in conjunction with the application allows the machine to clean your room to the best of its ability, to get it right down to very low AQI, and that allows us to cater for all different levels of pollution. And I think what's interesting is indoor pollution and outdoor pollution, the awareness is very low. So I think the awareness of outdoor pollution is very high. The effect of it isn't so much. I mean, we've I don't know whether you've seen them, but we've got some interesting videos of interviews with people in the India market who were saying that I live in a very polluted area, and I smoke, but because I smoke, I'm now immune to it. So I don't need to worry about air pollution. So from that extreme all the way to people who are aware. Indoor air pollution is very important. A lot of people will say if there's a pollution event in the house, just open the windows. So if you're in Mumbai or somewhere like that and you're near a road, opening the windows is the last thing you want to do. But if you keep your windows and doors closed, all of the pollution that you've got inside, you can't win. You go outside, you're polluted. You stay inside, you're polluted. So what the purifiers do, and the auto mode helps us with, is to be able to deal with that specific issue. So huge pollution events indoors in a sealed environment, the machines can deal with those. So and it's still early days. I think we're still quite new to the purifier market. We're not new to the filtration market, because we've been doing that with cyclones and filters on our products. Taking that technology incorporating it into our filters, and with the addition of carbon as well, Tresh impregnated carbon, auto mode, application, as one bundle, that really helps us deal with pollution. Sorry, long-winded answer to a short question, sorry.
But when you talk about learning from India, so like I think one of the feedback that we've all given here is when we use the air purifier in India, the app almost never shows an acceptable level of AQI.
Mm-hmm.
That's because of how polluted Delhi is, or the country is at that time, right? So, am I essentially saying that the air purifier is not going to bring me down to healthy levels ever in India?
But indoors
Because
as well.
no, it's not. That's what I'm saying.
Okay.
That if it's not going there, then that's the learning that comes from India, right? That that this air purifier is not taking me there.
Yeah.
Then what changes there for India?
So what we're seeing is that the application is giving us lots and lots of really useful data. So we can see in what areas, in what parts of India we're seeing really good air purification or really bad air pollution. And from gathering that data, we can then make improvements, whether we do an over-the-air upgrade, or whether we adapt a new type of filter, or we do another change. We're constantly gathering that information. And throughout Dyson we have research teams, we have teams that do development and put products into production, but we also have continuous improvement teams as well. So once you've bought the product, the beauty of using the application or having internet use is we can do updates across those areas.
Speaking of any hurdles that you would probably have come across while designing or developing the air purifier, something that was really, really significant and you really were glad that you overcame it.
Glad we've got 40 minutes. So trying to keep the product, to make sure that it's high performing, it meets all of the specifications that we've been asked to hit, whether it's level of purification of fine dust particles, purification of gases, and making sure that it has the right acoustics level, because we could probably make an amazing purifier that you couldn't sit next to because it's too loud. All of those challenges, there's not really one thing that comes with it. It all comes as a bundle. I kind of think about it, from the 80s when I had a stereo with a graphic equalizer on it. You're moving the difference. So I want it quieter, but then the filtration's not so good, and then I want it more powerful. So trying to get the balance into a product that we feel is really market leading and performance is high. Trying to get those areas perfect, and the more dense we make the filters, the more we have to manage the airflow. The more we have to manage the airflow, the more our acoustics is getting affected. So that whole system, the system is the difficult part and the real challenging piece. And unfortunately or fortunately, depending on how you look at it from an engineer's perspective, it's not a simple problem to fix. It's not, on Monday we will fix the systems issue. It's constant development through the whole project. So those are the real big challenges for us. I mean, there are smaller issues where we might not, we might get a last minute change that we don't like the way the buttons work, so we'll have to change that really quickly. But those are quite simple. The technical systems approach is really quite challenging.
So what's a typical day for a Dyson engineer at the STC?
At the STC, we never go home. We're here all night. So we usually here pretty early, and we're usually here pretty early to catch up on all of the work and the communications we get from the UK. So the first part of the morning is catching up and then setting out the tasks for anything new that's come across and that's not already included in our work plans. Then there's constant problem solving. Not problem solving in the fact we know that the problem's there, but we're trying to do things quickly, and we're trying to do things to a very high spec. And we're challenged never to do anything the easy way. So I could probably see a really easy way of doing something, but it means that the product will be twice the size and noisy and twice the price, but I could do that really quickly. So we're constantly challenging ourselves and each other to come up with new ways of doing things faster. From 4 o'clock onwards, we're in communications with the UK again, following up. That's kind of my area, but we have our. You've done a tour, haven't you? So you've seen that we've got our analysis people who are looking at complicated CAD models of how the product works. We've got our acoustic guys who never want to come out of their super quiet chamber because they're all geeky and they're doing their graphs and other bits and bobs, and the electronics guys doing their AI, and so there's a big mix, and for me I have to bring all those people together to try and make sure that they're delivering the one piece. And at Dyson we're quite lucky because those guys have got state-of-the-art stuff to play with, and that's what they like doing, so they're happy in what they're doing. So trying to drag them out of, if I just another week and I'll have this doing something else, or we're constantly playing with that level.
But how often do you have disagreements in terms of design, in terms of innovation, and what do you do about it? How do you approach a disagreement among team members, the innovative? We
never have disagreements. No. We have challenges. It really depends. So, for example, if there's a safety problem, there's no disagreement. We have to fix it. If there's a user interaction issue, so somewhere where we're disagreeing on how the user will interact with the product, we will define a way of doing more user trial tests and looking at the better ways of doing things. The majority of our arguments are usually based on performance. So how do we get the very best performance, and how much is it going to cost to do that, and what is the right way of doing it? So I think we're quite lucky because we always have the same end goal in mind, which is the better product. It's how do we get to that point? So it's usually, well, I need 10 people to do this, but then Joe is over here saying, well, I need 30 people to do that, but I need £100 million and 10 more people. So trying to get those normal priorities in the right place.
I actually have two questions out of this in terms of, disagreements in terms of maybe the design or innovation of a new product, one, and how you're talking about resource and budget allocation. So is there a process to that also that you guys internally adapt, or a system to go about?
If I'm totally honest with you, no. We're quite free on process. So we have very basic process. Don't spend way too much, but we're a privately owned company, so if we want to and we feel that there's a really good piece of technology and we want to take the risk at the time and put the money into it, we will escalate that, and 9 times out of 10 the product is king. So whatever's best for the product, we will try and implement that, and that has its own problems because we also want it for a season, so we'll be aiming to get products into India for the October-November, but we might find that there's a brilliant new way of teleporting dust into space or something, I don't know, and we'll try and get that on. So the process is very loose, but we're lucky in the fact that we can be very loose with that process. We're not bound by, I don't really like process, if I'm totally honest with you. I like to be able to just go for it, but we have to have a small level of process.
And design, the freedom to design a new product or a new segment altogether?
Well, I think the £8 million a week kind of says for itself. We've got, for every one product we put to market, there's probably 50 or 60 that are still on the drawing table, some which are way too advanced and we don't have the technology to implement it yet, or the technology is the size of a house and we need to spend 6 months or a year bringing it down to the right kind of size. And I think when we set the goals earlier on in the project, we know what we're trying to design or the problem we're trying to fix. I think what's slightly different for us is we know what that problem is we're trying to fix, and we will continue to develop quite late on into the development phase to try and fix that problem. My previous company, even though that was a long time ago, we had a very fixed specification that started on year one, and you just delivered that and nothing changed in between. With Dyson, we might discover something halfway through that we want to put on it, and we'll go for it. And myself and my counterparts in the UK will talk about how we want to do that, what the risk is, what the financial burden might be, and then decide 9 times out of 10 to go for it. So we're used to it. We're kind of used to a very positive but proactive way of making sure the products are always very good.
So continuing on what you just said, usually in the past few years we've seen this cycle of every 8 months, 12 months, 2 years, a successor to a product has to launch in the market. Is that something that you guys also adhere to, that okay, we have one now, we have to get something new out in 2 years, or it's all based on the R&D and it's only when you need something new that you are going to launch it in the market?
It's only when we feel that we've made a step change, we will launch it. It's kind of we could make a small, we could make the screen slightly bigger and launch. This is our new product. The screen's slightly bigger. That's not fun for an engineer, and really, it's gimmicky. We want to make sure that the next product is a step change better. So it's quieter. It's got better filtration, and we did an awful lot of deliberating over whether or not we would enter into the application area, because everyone's doing it. But we wanted to make sure that if we did start to use apps, that it would actually have a really good impact on the customer, whether it's worth doing it. And for an app to be able to allow you to interact with your environment for the first time made a big impact on us. So when your purifier's sitting in your room purifying, how do you know what it's doing? When you're using our vacuum cleaners, you can see the dust going inside. When you're using supersonic, you can feel it's lighter, quieter, and better. When you're looking at the purifier, air's coming out of it. But now you can look on the app and see, well, actually, it's cleaned my house. So we really felt that was an advance in what we were doing, as opposed to just adding something that is the trend.
Can you talk a little bit about the aerodynamics? I mean, where that inspiration came from? I mean, we have seen aerodynamics being very effectively used on Formula 1 cars.
Yeah.
I mean, it kind of resonates with that. Can you just talk a bit about airflow and how this helps?
Well, I'll kind of tell you a little bit about how we first decided to go for a bladeless fan and how that was born. When we were developing hand dryers, so quite a lot of our technology comes from the vast amount of testing we do. So we'll do a test, we'll look at the results, and one of the guys will look and go, there's an interesting thing that's happened there. I wonder what that is. And he'll wander away from his key task, and he'll start to find out what that anomaly or change was. And 5 times out of 10, 9 times out of 10, that leads to a new technology somewhere, because we've discovered something. When we were doing hand dryers, we noticed that when we were switching the hand dryer on, not only were you getting air out of the air blades themselves directly onto the hands, that we noticed that lots of air is getting drawn in from around the whole machine. And then we started to think, well, that's interesting. We had computer models of it. I wonder what we could do with that. And so we have rigs which look like hand dryers, which are actually fans and all kinds of strange stuff. And that led to the development of air amplifiers. And then as we progressed through air amplification, we wanted to find ways of getting the very best performance. So different impellers. So if you look at some other purifiers, they have a traditional flat propeller in the bottom of their machines, whereas we have a mixed flow impeller, which allows us to work products using pressure. and that helps with acoustics, but they're quite difficult to make. So it's another example of how we've wanted to keep a really good product format, but we've had to use difficult engineering to do it. And airflow, so air running through bits makes noises, so we have to make sure that we are managing that airflow very well. So there's features inside the product which will help to do that. So let me have a look here. So of course we've got the filter, which you can see on the side here, and then the carbon filter. Oh, here we go. Yeah, let me move that for you. And then there's a chamber in the bottom here. So you may think that that's doing nothing, but what it's actually doing is it's helping us manage the air and the way the air is moving. And there's you can't really see it very well here. There's a shroud.
Yeah.
That's helping us break up the airflow as it enters into the product. So instead of having lots of air spinning around randomly, we have to manage it to make sure that it's we're getting the best performance, so it's smooth and it's not making too much noise. And then when that goes through into the bottom of this area here, so we have the impeller and the impeller wall, which is this part here. You might not be able to see it, but the gap between the bottom of that impeller and the impeller entry point here, that's really, really important to make sure that we get the right acoustics. If it's too big, it makes loads of noise. If it's too small, you don't get the airflow and it makes a whistle. So when we're making 10,000 of these a week, you've got to make sure that that is perfectly put together. So there's manufacturing challenges that come through that as well. Once it comes out of the impeller through up into this area here, we're using this part to smoothen the air across the top. Because when the air goes, I mean, everyone's done the bottle, you know, you blow across the top of the bottle and you're making noises. You know, we see those things happening all over the place. Quite simple pieces contribute to very small noises. So the last thing you want is in the middle of the night, you're on night mode and you can hear your machine making a funny noise. So, you know, I've spent hours sitting in the anechoic chamber that you guys have been in there, sitting, listening to see are there any strange noises. So I don't know if they showed you the graphs, etc., that we have in there, but we can pick out all the different aspects of the noise from the product, for what noise the impeller's making, what noise the top bearing's making, the bottom bearing's making. And the quieter we make the product itself, the more it exacerbates the noises that we get from the inside. I mean, just remember one of the problems we had when we very first started on this was we could hear one of the resistors making a squeaking noise. So we had it on speed 1 and we were all in the chamber and where's that noise coming from? So we then do all the analysis and it turns out it's not an airflow or a motor noise, it's something else. And then we delve down into the next phase and we find that it's a resistor vibrating, so we have to change that resistor. Once the air comes through, I mean, this foam, high density foams in here to prevent noise and swirling sounds coming through. And then as we get up into this area here, you'll notice that our earlier fans are much lower in this section. Partly because we wanted to keep the footprint of the product to a certain size. But the more work we've done, we've realised, well, we need to keep this to a certain level. So the amount of airflow we have going in, the amount that goes through the machine, at the speed and the trajectory, the shape of it when it's coming out, the next cavity that it moves into has to be a certain size and shape to make sure we're not getting other noises. And then eventually it runs around the entire amp and how we manage the air coming out of the front slot. That's important because the speed, the amount and the volume of the air is all dependent on how wide that section is. If you make it too small, you don't get enough and it whistles. You make it too big and you can't feel it and it makes a hum. So that equalizer I was talking about, you know, you're like, I've solved it, and then you make a prototype, you test it, oh, there's a whistle. So it's exciting and challenging, and there's an awful lot more to it than the average person thinks.
Speaking of the filters, now it is in 2 semicircles rather than the single circle it was, and the carbon filter is separate as well.
Yes.
Compared to the previous model. Is that only for the ergonomics of the user changing it, or is more benefits to that?
It's a bit of both. It helps us change it. It helps us with the carbon filters. We wanted to add more carbon into the product so we could filter more of the VOCs. Depending on what areas you're using, these filters we can use those filters. The usage of those filters is different. So sometimes if you're in for example, if you're using your purifier and you're painting the house, you'll get lots and lots of those VOCs coming in. The particulate filter will clean the particles. The VOC filter will get all the smells and nasties. So you can change them, make that easier to change. It has an acoustics benefit as well, and it helps us manage the airflow.
Since we have spoken a lot about acoustics, I mean, are you guys working with a set decibel level? Like this particular sound would be feasible for a household, or say when the machine is set on a desk?
It's a good question. When we are So our research team will be like, okay, we're working on a new purifier, and we have something called a vision specification. So what do we want it to be? And it will start off, we want it to be 0. Okay, and then as the product develops, we'll need to understand how much airflow we want, what purification performance we want, and then as we move further up, we'll have a threshold. So 100 decibels, definitely not. 50, well, 50 is actually very quiet and very good. So in between there, so 60 is probably the top limit, and we'll set ourselves a limit that we must not pass, and a limit that we really want to try and get to, and we'll work towards those pieces. But again, depending on the other spec items that we have. But yeah, acoustics is something we're always looking at, and worked in vacuum cleaners before, and vacuum cleaners there's a certain level of acoustics that you have to accommodate with. But with a purifier, with something that you're using at night time, it's not just about the wind noise, it's about all those other potential annoying squeaks or whistles and tone. So we have a top level sound power, so when you're in speed 10, how loud it is, but we also have a sound quality specification as well. So it could be 60 decibels, but a really horrible screeching noise, or 60 decibels and a nice airflow noise. So we restrict ourselves to the right level of noise, not just the acoustics, but also the quality.
How do you determine the compromises that you need to make? What is the sort of thinking here? How do you go to, maybe he won't need this at this time? Or
so I mean, that's a good question, and we debate an awful lot about the night mode. And for me, the night mode's a starting point, or that acoustics level's a starting point, and that's why we make it adjustable. So when you go into night mode, if you want to do something very quick, very tired, you just want to stick it on a quiet mode, you go in there, but you can move it out of that. So if you want more flow, you can still have it in night mode. And night mode's an interesting one because for me, the thing I don't like about the night mode, before we didn't have night mode, is when I go to bed at night at the moment, the monitor of my computer, it's got a little light that so that's on. Then my USB charger next to the bed, that's got a little LCD light on. My phone, everything in my room, there's about 10 things and they've all got a teeny little light on, and the whole room's lit up. And I've got blackout curtains so no light comes in, but I'm lighting it looks like a little fairyland. So one of the things we did on night mode was our very first purifier, the light stays on and it's so bright and I used to place one of my children's little teddy bears used to sit over the front of it, so I wouldn't see the light. But the night mode, the key is to make sure that it's dull enough, slightly digressed from your original question, but the adjustability is where we plan that, because I can't, everyone's different.
No, but are you sort of setting out on a priority basis? So for example, with the night mode, the way I look at it is that the consumer's priority here is going to be less noise.
Yeah.
So that's the first thing to achieve, and then we go to what's the highest amount of cleaning we can do with no noise.
Yes.
Or almost no noise. So when it comes to these compromises that we make, that you're making while designing the product, that also will affect the claims at the end of the day, right? What the air purifier can do and cannot do.
Yeah.
So how do I, as a consumer, how do I know what the best setting for, let's say, a Dyson air purifier would be? How should I know what's the best way to run this in my home?
Yeah. Well, I have it on auto mode. That's the best way.
Okay.
Because then you're making use of the dust sensor, the VOC sensor. There's humidity and temperature sensors in there as well, and the product will be sensing it for you and cleaning as it goes. That's the best point. I mean, overall, we want to make sure that we're not we're not pushing a specification onto the customer, and adjustability is one of the key areas that we tackle that. Because if I ask 100 people, I'll get potentially 7 different answers and varying different versions of those. So being able to make a choice is the key.
In fact, since you mentioned the auto mode, it's not related to what you were talking about. Does the air purifier in any way sense when the AQI can't go beyond a particular level on the auto mode? Like, so I mean, ideally, if the AQI is still at high, not high as in harmful levels, theoretically it should always remain at 10, right? It should always say that it's not going down.
Yes.
So the level will come down based on AQI. But is there like a point where it decides that, okay, I need to remain at, let's say, 7 or 6 right now because this is just not working or something?
Well, it's constantly sensing. So these two holes in the side here, so the sensor that we have has its own little fan, and that's drawing air in, and the fact that we're projecting out and mixing into the room, we're pulling air towards the product as well. I think we do a demo in a big box where we fill the far end with smoke and you can see it circulating through. There's an algorithm that we put into the software which works on both the VOC sensor and the dust particle sensor, which has got 2 lasers into it. So the product's constantly sensing. So if it's constantly sensing a pollution, it will keep going. As soon as that starts to drop, it sees a drop in VOC or dust particle size, it'll start to ramp down to the point where it's in standby mode. And when it's in standby mode, the motor inside is still turning because we want to draw across. You can switch that on and off in the app if you want to. But the sensor's constantly drawing in, so it's always sniffing.
Pollutants can build up indoors, gases, allergens, and particles. So Dyson's purifying fans use sensors to detect them, capturing them inside sealed HEPA and carbon filters to clean the air. Then air multiplier technology projects 290 litres of air per second, purifying your whole room and cooling you in summer.